In this video, we're going to look at write caching again. We'll review the decisions that we had to make when we introduced write caching, and we'll also talk about the metadata that we need to introduce to support write caching. And then we'll look at the interplay between all these decisions that we had to make. So remember that we had two sets of decisions. The first decision was what we do when we have dirty data in the L1 cache. That is, I take a hit, I write data in the cache. Do I leave it there or do I immediately push it through to the source? That's the write through versus write back decision. The second set of decisions we had to make was what do I do when there's a miss? And so there's data in the source. Do I move it up into the L1 and then write it there? Or do I leave it in the source and just update it there? So let's review what those look like. So here we have some data in the cache. We have the favorite value of 42, and the application is saying, please change it to a 1. And the cache says, well, fine, I will just update it right in the L1 because I am a write back cache. And if I am a write back cache, once I've updated it in the L1, I'm done. There's nothing more that I need to do. However, if you are the person implementing that cache, all of a sudden there's this state that has changed and you need to know about it. So in order to implement write back caching, we're going to add a bit to the cache metadata that says this cache line is dirty. And the reason we need that bit is that when it comes time to evict that cache line, if it's dirty, we'd better write it back, right? Because if we don't, we will have lost the update. Now you might say, well, why don't we just write everything back? And the answer is that if we wrote everything back, that would be a terrible performance hit. And that a lot of times when we didn't need to write the data to the source, we would still be writing it to the source. So that's write back caching. Let's look at write through caching. So now the application once again says, I would like you to write this value 1 into the cache. And so we go ahead and we change that. And in addition, I'm going to push that 1 and I'm going to write it through to the data source. Now, in reality, I showed you those things happening one after the other. They don't have to. If you have a write through cache, you can actually do those writes in parallel. And so when we tell you that the time to write to the lower level cache is 6 times that of the first, you should assume that even if it's write through, you can do those writes in parallel, okay? So those were the decisions about what we do with the dirty data. Do we leave it in the cache or do we push it through? But now let's look at what happens in a miss. So this time you'll see that we don't have any data in the cache. And so the application says, could you please write this item? And the cache says, well, I don't have the item. So if we're in a system that does no write allocate, then we're not going to ever even allocate it into the cache. We're just going to send the message down to the data source and say, please write this value into the address, and we'll update it in the data source. Okay. Now, if you think about why you might want to do that, if your application is simply writing a lot of data and never reading it back, and it's not even making multiple writes to the same cache line, then this sort of architecture would be great, right? Why waste the time bringing things into the cache if you're never going to use them again, right? Now, we don't know that because application behavior differs and we don't get to change the behavior depending on the application, but the policy does make sense under certain workloads, okay? So now let's look at the alternative, which is write allocate. So again, we ask to write the value, it's not in the cache. And so this time, and there's 2 different ways we might implement this, and I'll sort of walk through both. So what you might do is the cache might say, I don't have this cache line and you want to write it. So let's read the cache line into the cache. Now that I have it in the cache, I would like to update it. And so I've read the data and I've updated. Now you may be saying, but is it a write back or is it a write through cache? And the answer is, great question. You can mix and match these decisions, and let's take a look at what makes sense. So across the top, I have the decision about write back versus write through. And along the left, I have the decision about no write allocate versus write allocate. And as I think we said in class on Friday, it is most common that when you have a write back cache, you do write allocate, because the assumption when you have a write back cache is that the data in the cache is valuable. You're going to use it again, either to do more writes or to do some reads. And therefore, even if you take a miss, it's worth creating that line in the cache so we can write to it. And so you get a very consistent picture if you have write back with write allocate. Similarly, if your cache is write through and you're always going to be writing to the data source on misses, then no write allocate makes sense because you've taken a miss, you're going to write through to the data source. Why bother making another copy and putting it in the cache? Now, what I'm going to claim is that those are the common, and those are the ones you will most often see. Write through with write allocate isn't completely bizarre, and we'll walk through that, but I'm going to claim that write back with no write allocate is a pretty unusual combination that you would be unlikely to see. So let's sort of see what happens when you have these two. So we have a write back cache, so we allow dirty data in the cache, but when we take a miss, we don't necessarily put the data in the cache. All right, so what would that look like? So the application is trying to write a value that isn't in the cache, and this is write no allocate. So we go down to the data source and we say, okay, I need you to write this value and you don't get to allocate the line in the cache. Well, what does that look like, right? We change the value. That looks a whole lot to me like a write through operation, right? We took a miss and we wrote it through the data source and we didn't put it in the cache, right? That's exactly what happens in a write through cache. So in the case where you take a miss on a write, it behaves just like a write through cache. And so calling it write back is a little weird. Now, how is it different from a pure write through cache? It's different in that if you had read the data first, well, all of a sudden you get exactly the write back behavior you want because it would be a hit. And so you could just update the data in the cache. So I'm going to claim that this is sort of a weird combination because depending on whether you read data and then write it, it behaves like a write back cache. But if you just write data without the reads, it behaves like a write through cache. And that seems like a bit of an odd combination. Not to say you couldn't do it, it's just that's the reason why you tend not to see it together. Well, we looked at that one. Let's look at the other. So that was write back with write allocate. What about, I'm sorry, that was write back with no write allocate. What about write through with write allocate? So what does that look like? So the application says, I would like to write some data. And the cache says, I don't have it. But we have a write allocate cache. So there are two different things I could do. One is I could immediately say, I need to allocate the line. So I'm going to read it from the data source. I'm going to put it into the cache. Now I'm going to update it in the cache. And because I'm write through, I'm now going to push that change back to the data source. Okay, that was okay. But there's another way I could do that. We'll call that case A, right? Case B is that the application says, write the line. And you say, okay, well, I'm a write through cache, so I don't have it in my cache. I'm still going to write it all the way through to the bottom, but I'm write allocate, so I'm actually going to copy it back into the cache. So my claim is that that's a little complicated. On the other hand, you really do get the advantage that if you then read that line repeatedly, it's in the cache and you get to use it. And the behavior is relatively consistent depending on whether you read or write first. And so you could imagine that there are advantages to having it this way. Okay, but I think you'll see that both of these last two situations are a little unusual. And that's why those two combinations that we told you about are in fact the cons you see most commonly. So what should you take away from all this? Well, number one, make sure you understand what these words mean. So if somebody says write back, you know what it means, okay? Secondly, some intuition about which policies are used. If your cache blocks are really big and your storage is really slow, and this is what happens when you're talking about disks or even flash, you will almost always have write back with write allocate. Okay, so when we look at file systems in Unit 4, those are write back, write allocate caches. And even when we look at the virtual memory system in Unit 5, we also treat that like a write back, write allocate system. And so where we're going to go is we're going to give you some practice thinking about when these policies might make sense and when other policies might make sense.